the next word problem says a 100-kilogram mass is at rest on the floor. Find the normal force on the mass. Alright, so go ahead and pause, try to solve this word problem, and when you're ready, unpause. Alright, so let's see what we have. There's a 100 kg. So kg is kilograms, so this is a mass. And we're trying to find the normal force, Fn. So this is not enough information, so let's try to draw a picture to see what's happening. So this is the ground. You have some kind of an object, there's a crate here with a mass, m, and we're trying to find the normal force on it. So first, because this crate has a mass m, gravity is acting on it with the weight of the object. So gravity is acting down, so it's going to be about minus fg, the weight of the object pointing down. But the object is stationary. The only way it stays stationary is if there's a force that balances gravity. In this case here, this is going to be applied by the floor. So the floor is going to exert a force opposing gravity in the opposite direction, and that force is going to be the normal force, which is the one that we want. So first, let's get the weight. So the weight of the object is going to be just mass times g, so that's going to be just 100 times 9.81. So the weight of the object is going to be 981 newtons. But what they want is a normal force. Luckily though, because this system is balanced, that must mean that the normal force is equal, or balanced in the vertical direction, so that must mean that, or it's stationary in the vertical direction. The normal force is going to equal the weight. So the normal force is equal to 981 newtons also. Alright, so try this one. We have a 6 kilogram crate is at rest on the floor with a coefficient of friction of 0.2. Find the force of friction on the crate. So go ahead and pause, try to solve this, and when you're ready, unpause. Alright, so let's try to get an answer for this one. So first number is a 6 kg, which is a mass. And the next number is 0.2. This is just a number. And that's it. And we want to find friction. So let's again draw a picture to see what's happening. So you have a crate. It's at rest on the floor. It's not going anywhere. The crate has a mass m. And the only reason what keeps it stationary is that there has to be a frictional force. So there's a force of friction pointing in this direction. Let's just say if you're trying to push it to the right. And so we're trying to find friction, but we need to also look at the other forces present. Because this object has a mass m, gravity acts on it with its weight, so then the weight always points down, so there's going to be a weight Fg. And just like with the last word problem, this object stays stationary, so that must mean that there's a force to balance out gravity, and the force that balances out gravity is a floor here, and the floor exerts a force opposing gravity in the opposite direction, and this is going to be the normal force. Okay, so now we have enough to solve the word problem. So first, easiest thing is to get the weight first, because we have the mass. So you can get the mass. Yes, you can get the weight. The weight is going to be mass times g, so 6 times 9.81. I'm just going to leave that number as is. And just like before, this thing is stationary in the vertical direction, so that means that the normal force is also equal to the weight. So this is also 6 times 9.81. But what we want is friction. And we know that friction is related to the contact between the floor and the crate, or it's related to the normal force using this equation. So friction is going to equal the coefficient of friction multiplied by the normal force. And the coefficient of friction is just a number, which is this 0.2 here. So we can just plug in. So friction is going to be 0.2 times 6 times 9.81. And that will give you a frictional force of 11.77 newtons. All right. So let's try to solve this one. It says a person pushes on a 50 kilogram box with a force, but the box remains stationary. If the coefficient of friction between the box and the floor is 0.6 newtons, find the force that the person exerts on the box. So let's write down the givens. 50 kg, which is a mass. And next you have a 0.6, which is going to be a number. And that looks like that's about it. And we want to find the applied force. So let's draw a picture. This is the box. The floor is rough. And so the 0.6, that's going to be the roughness of the floor, or the coefficient of friction. And the box is resting on the rough floor. Now the box has a mass m. Anything with a mass, gravity acts downwards on it, so it has this weight pulling down with a force of minus Fg. But this crate remains stationary in a vertical direction, and the only way that's possible is that there's a force to balance gravity. And in this case here, that's going to be the floor exerting a force upwards on the box with the normal force Fn. And now in the horizontal direction, you're trying to push or apply a force on the crate, but it's staying stationary. And the only way that that's possible is that there has to be a force to cancel out the force that you apply, and that is going to be the force of friction pointing backwards here. Alright, so we have all that we need. So now let's try to solve this. First, if you can, it's always get the weight. That's always going to be easiest. So the weight is going to be mass times g. So that's going to be 50 times 9.81. And through the same reasoning as the last word problem, in the vertical direction it's stationary, so that must mean that some force balances our gravity. In this case here, that's going to be the normal force. So the normal force is also going to be 50 times 9.81. And now we can now get friction, because friction is related to the normal force. Friction is going to be the coefficient of friction times the normal force. So that's going to be 0.6 times 50 times 9.81. So the problem is not asking for friction, it's asking for the applied force. And just like now this is in a horizontal direction, it's stationary, and the only way that that's possible is if there's a force, if the friction is bound, or the applied force is balanced by friction. Or another way to say that is that the applied force is equal to friction. So the applied force is also going to be 0.6 times 50 times 9.81, and that will give you 294.3 newtons.